So today we will discuss requirements, considerations and approach for deployment of holistic AI solution for enterprise product development. So what are the fundamental principles for such a holistic AI solution? It should be secure and enterprise specific, should provide acceptable performance, and should still be manageable. Our data should be secure and should not leave the enterprise boundary. The solution should understand development ecosystem of my enterprise. It should be aware of relationships and history of various subcomponents of my software. It should be aware of my policies, customizations and guidelines. And yet, it should be manageable with respect to requirements of hardware and GPUs, as well as keeping pace with almost weekly advancements in AI models and technologies. So, we are not left out in our adoption of better ways of solving a problem. Let us discuss fundamental building blocks for such a solution. We should create a multi-dimensional knowledge hub which has both generative and deterministic components, such as language models, classification and other machine learning models, knowledge data stores, etc. The knowledge hub continuously learns from data in public domain, such as millions of GitHub, GitLab, Bitbucket repositories, project management tools like Jira, content management tools like Confluence, etc., as well as from industry-accepted source of truth systems such as vulnerability database and language and package repos, etc. As we move towards manageable and secure AI, we need to move towards uses of large group of task-specific small or medium language models. In this case, role of training data becomes single most important factor for the AI performance. It is not enough to learn and train using large but generic data. Our raw data needs to pass through data curation pipeline. We need to curate authentic, to the point, use case specific training data covering complex scenarios. Curation of authentic use case specific training data is often a very involved expert process. The knowledge hub acquires generative and deterministic brain and understands how to execute various tasks such as framework and language upgrade, new feature development, etc. Knowledge hub also understands impact of proposed change on aspects like compatibility, security, performance, and maintainability, etc. Knowledge hub needs to update itself continuously. For example, its task-specific models should keep getting updated with newer and better versions. For instance, a specific task could be better handled with further training with more data or newer data. Or the community may come up with newer models and methods that may be more suitable for a given task. Generic knowledge hub components should be regularly synced to a customer environment. Customers should be able to customize their generic knowledge hub using the enterprise data such as code repositories, policies, and customizations, and let it learn from relationships and history of various subcomponents of their software. So we do need pipelines to extract raw data from various enterprise sources, curate the raw data for various use cases, and further train and fine-tune specific task models with the curated data. Typically, this training is a much lighter process as compared to the generic knowledge hub training. So how do we actually use these models and other knowledge hub components? We need a serving layer which basically provides a runtime environment that uses knowledge hub components to orchestrate execution of various tasks. Selected customized task models can be promoted from knowledge hub to serving layer for actual use. Serving layer has components for inferencing to generate required code, instructions, documentation, etc. It also has components to orchestrate complex product development lifecycle by executing various release themes, as well as components to identify compatibility, security, performance, and maintainability impact for a change. Serving layer is directly or indirectly used by various users such as developers, architects, product managers, etc. So how do we deploy such a solution? There are many ways we can deploy such an AI solution, and in fact, we would need multiple deployment options. But let's discuss one such approach today. First of all, we need a components repo, which is regularly updated by usual CI/CD pipelines, LLM ops, ML ops, that brings various qualified knowledge hub and serving layer components for production use. We also need another component, let's call it base server. Base server provides a nice user interface that admin can use to logically group together various required components for a customer. For example, based on a customer subscription, it only picks up models for a specific use case or language, etc. Customers can also see required hardware resources for specific components and models, and how different hardware choices and choice of specific components and models will influence overall performance. For example, for inferencing speed and inferencing quality. A customer can log into base server and initiate a remote install of a very lightweight edge server in their environment, or download a script to run in their environment to install this edge server. Edge server in turn creates a Kubernetes environment and sets up customers' knowledge hub and runtime components inside it, as well as any other required external services, for example, data stores, monitoring, etc. It keeps the customer's knowledge hub and runtime components up to date, but in a controlled manner. Edge server regularly interacts with base server and syncs all the artifacts subscribed by a customer, for example, container images, files, and objects required to run subscribed use cases. These new components are visible to customer admin in Knowledge Hub UI. These can be promoted for actual use to the runtime environment in the serving layer. When there are newer versions available, most of the updated components can be directly promoted. However, if a task model has already been further trained and customized in customer environment, and now you have got a newer and better version of it available, you need to bring down the newer model down to customer environment and bring it to the same level of enterprise customization. It cannot be directly promoted until we bring it to the same level. Rather, it should first go through a transfer learning pipeline, where the incoming newer model is trained again with the help of same original training data and the earlier model. This process has many nuances. So how do you actually deploy this solution? For the actual deployment, one of the supported methods is to use GitOps. So over here, we maintain customer infrastructure as code. For example, Kubernetes YAML files in a customer-specific Git branch. For instance, here we have a task-specific model with version 1 that is currently deployed in customer environment. When we have version 2 available in our production lab, once base and edge server interact with each other, it is visible in customer knowledge hub. Once customer approves promotion of version 2 to the serving layer, it triggers the GitOps pipeline. We update the infra code here to version 2. As this branch is being continuously watched by a GitOps agent like Ergo CD or Flux running in customer's Kubernetes environment, it detects this change and rolls out version 2 model for this task. Very similarly, any other runtime components or knowledge hub components will get updated in the same manner. You can choose various rollout strategies such as rolling update, blue, green, A, B, canary, etc. For example, to ensure no downtime, or roll out initially to a subset of users. In terms of deployment, one major aspect of overall solution should be to optimize the use of customer's hardware. A customer should be able to compare various options for required hardware, timelines, and AI performance for their use cases, as well as how hardware scale up or down will affect performance of overall solution. Customers should be able to recycle and reclaim hardware. So for instance, customers can choose first to use their environment for a specific tasks, such as some framework or language upgrade, complete it, seamlessly reclaim underlying hardware, and then move to different tasks using the same hardware. For instance, now for security improvement or implementing a new feature. So today we discuss requirements, considerations and approach for deployment of a holistic AI solution for enterprise product development. Stay tuned as we will bring in further insights in our next session, where we would be talking about the art of possibilities and a streamlined approach for addressing this bigger industry vacuum leveraging AI. Thank you.